Please visit urbanwaters.in for the apartment case studies. Before designing and implementing any intervention, it is recommended to know about your apartment in detail. All this information are critical to plan the sustainable water management initiatives in your apartment. The main aspects to document are understanding your apartment history, the land use and occupancy, water supply and wastewater infrastructure, the other infrastructures, the neighborhood of your apartment, and the present water balance of your apartment. Document all the information and update it regularly. It will also help the new Resident Welfare Association when they take over. Now we will go through the above aspects in more detail. Understanding your apartment history can include what the land was used before the apartment was constructed, were there any open wells and are they retained, when the development was completed and when it was handed over to the Resident Welfare Association, the total land area, breakup between different areas, number of flats, current occupancy and the estimated future occupancy in phases, who is responsible for the maintenance of the apartment, and the common infrastructure such as the clubhouse. The land use is generally divided into 4 categories: the plot area, road or paved area, park and open spaces, and civic communities. For the purpose of this video, let's assume the apartment area to be 1 acre. If you observe, the major land allocation is generally given to the built up area, which is about 55%, the road area is about 30%, park and open spaces is minimum 10%, and civic communities is minimum 5%. What are your different water supply sources? How many open wells and bore wells in your layout? How many are dry? How many are yielding at present? And the volume of water available from different sources. Where do you store all the water and how do you supply it to the individual flats? Is metering done at source like bore wells, open wells, municipal supply to know how much each source is supplying? And at critical points such as inlets and outlets of storages, and consumption metering to know the exact end usage of water. Also identify if there are any leakages in the storage structure and in supply pipes, which is essential to know what the real consumption is. Ensure your water quality system is not an overkill and water quality is monitored regularly at the source level too, in addition to water quality monitoring before the supply. Wastewater is another source of water for your apartment. Know how much wastewater is generated and treated, the type of wastewater treatment system, its operation and maintenance, regular monitoring of the wastewater quality, the end use of treated wastewater, and how you are disposing of your excess wastewater. When you do water interventions, we should make sure our gas, electrical and communication lines don't get disturbed. For better coordination and maintenance, label all your different pipelines, chambers and other infrastructure. It is also very critical to know about your neighborhood. If there are any lakes, open wells, the depth of bore wells and water quality in the surrounding areas, and also if there is any flooding issue in the surrounding areas. You will have to consider all this in the interventions to be planned. Calculate your water demand, water inflow from different sources, any rainwater harvesting infrastructure for storage and recharge, the outflow of treated wastewater and how it is utilized or disposed of. What is the water scarcity at present and the water scarcity anticipated in future when the occupancy increases. Your water balance depicts how sustainably you are managing the water inside your apartment. It is useful to categorize water demand into different types since different purposes require different quality of water. The cleanest water required for drinking and cooking can be categorized as the first category. The second category of water for bathing, washing and cleaning need not be super clean. The third category of water required for flushing and landscaping can be utilized from the treated wastewater without wasting the fresh water. Considering that per person water demand is 135 LPCD, water demand for a family of 4 persons is 540 liters per day and likewise for the whole apartment with total number of unit families, 54 KL will be required. In urban areas, per person daily demand is designed for 135 litre per capita per day. But we have observed that the consumption is sometimes up to 250 to 300 litre per capita per day. For sustainable water management, it is very important to bring down the consumption to 135 LPCD or lower through the interventions which will be discussed further. Resident Welfare Association has the responsibility of taking the complete knowledge transfer from the developer. Otherwise, there might be challenges in effective interventions to be planned. Now that you know how much water your apartment needs, different water sources, the water supply and wastewater infrastructure, existing rainwater harvesting infrastructure, and your layout's present water balance, let us see with all this information what you can do in your apartment, how you can meet your water demand sustainably.
Once you know how much water your apartment consumes, how much water you require, you can also think about what are the things that you do next. So a couple of simple things that you can do once you know how much water you consume, can you bring down your water demand? And very practically, how do you go about doing it? What all does it require? The next thing is, you know that rainwater falls on your campus, you know how much. Can you store it, use it? Can you use it for groundwater recharge? Can you monitor your borewells and see if the yield in the borewell is coming up? What happens to your waste? What can you do with your wastewater? Your treated wastewater, are you using it optimally? So let's just see what are some of the simple and some of the not so simple things that we can do. Say you measure, like we said, you need to know how much is the water demand per house. How do you know that? You have to install meters. In apartments, because there are multiple inlets to each house, one through the kitchen line, sometimes to each of the bathrooms, it becomes a little complicated, unlike for a single house to install meters. But now there are solutions, both digital and analog, using which you can monitor the water consumption in each household. What has been observed is that the moment you even install these meters, you know the numbers and you publish it, water demand actually starts to come down. But what can take it to the next step is once you actually start to bill the apartment for the water that they consume. People who consume below 20,000 litres a month are charged very nominally. The nominal charge could be anywhere between, say, 15 to 30 rupees per 1,000 litres. But those who are consuming above 40,000 litres a month pay much more heavily, say even at 150 rupees per 1,000 litres. Some of these things even school children know, but we often forget to implement them. What is it? Turn off the taps when you're brushing, when you're shaving. Identify if there are leakages. In fact, it is said that dripping faucets, dripping flush tanks, which you mean to repair, and the losses can be anywhere between 5,000 to 50,000 litres per household per year. Taps, sometimes we don't realize, when you turn it on, there's about 15 litres of water that flows out per minute. By fitting aerators, you can significantly bring this down to even lesser than half. It's a simple thing you can do. Water tanks overflow. When we switch on our pumps and we are pumping to our overhead tanks, make sure that you fixed automated water controllers and water level controllers so as to avoid any form of overflow. A simple thing that you can do is a flush tank. Every time you flush, a certain volume of water flows out. It could be 4 litres, 6 litres. You can displace a certain volume of water by taking a bottle that's filled with water and placing it inside your flush tank. This way, every time you flush, you're saving 1 litre of water. Most houses these days have reverse osmosis filters to filter their water, drinking water. In certain cases, it's not even really required. So the first step is to figure out, do you really need a reverse osmosis filter? Assuming you do, what happens is that for every litre of water that is filtered, close to 3-4 litres of water, on an average, there is a variation, but a fair bit of water is discarded as reject. This water, you can test the TDS of this water with a simple TDS meter, or even if you don't, make sure you collect this water. You can use it to rinse vessels, to wash clothes, to clean surfaces, to clean bathrooms, to swab your house. There are various purposes. To water some of your plants, you can certainly use this water. In fact, what we say is that every drop of water saved is one drop of water that you have lesser to buy. It may buy or source from elsewhere. So when we look at our various sources of water as river water, tanker, borewell water, actually demand management is also a source of water. Instead of 100 liters, if you need 80 liters, you have saved 20 liters, and that's how much lesser you have to buy. So use water judiciously, be conscious of your water use. Let's take the example, as was stated earlier, of an apartment that is, let's say, on 1 acre of land. Like we already know, Bangalore receives about 974 millimeters of rain on an annual basis. What this results in is, if you take an average apartment block, annually there is about 2000 kiloliters of water that is running off from the rooftop. Similar, and not just from the rooftop, there is also runoff from our paved areas, from our roads, from our gardens. When you sum both of them up, you have close to 3000 kiloliters of water that is running off from 1 acre of apartment block. Now the question is, what is it that we can do with this rainwater? In apartments, for rainwater harvesting, here are the two things that you can do. All rooftop water can be filtered and either stored for future use or used for groundwater recharge through recharge wells. All runoff from paved areas and other kind of unpaved areas can be redirected into recharge wells for groundwater recharge. If you look at rainfall, rainfall is measured for the rain that you receive over a period of 24 hours. So let's say an average rainfall in Bangalore is 30 millimeters. 30 millimeters of rain received over a period of 24 hours. When it falls on an apartment block that's located on 1 acre of land, perhaps the rooftop is about 2000 square meters of rooftop, for a 30 millimeter rainfall over the period of 24 hours, we receive 60,000 liters of runoff. This water can be stored in a sump. Let's say you have an underground sump of additional capacity of 15,000 liters, you still have 45,000 liters of water that you could send to recharge wells for groundwater recharge. Rooftop rainwater, which is coming down through downtake pipes already, can easily be filtered and stored and used. To store it, you could either build a new underground tank or a sump, or you can even make use of your existing sump. Water that's running off from paved areas, from roads, can be redirected into recharge wells as structures that can put water into the ground. How does it work and what does it really look like? It's nothing much. It's really a deep hole into the ground where we are tapping into the shallow aquifer or the weathered zone. Once we dig this hole into the ground, it's normally dug by the community of well diggers called bovies or the Mannuvadars. So, and there are specialized skills to dig, say about 3 feet in diameter and 20 feet deep into the ground. Once you dig this hole, you line it with rings, concrete rings that are readily available. They are placed one on top of the other, and this really provides structural stability to this hole that you've dug in the ground. The rings are normally smaller in size than the larger pit that has been dug. So the annular space between the rings and the pit is filled with jelly stones or 40 millimeter aggregate stones. All of this ensures that the soil doesn't cave in. Make sure that the well, because you're building this in an apartment in common spaces where there could be children, adults, the well has to be covered from on top. It can be covered with a concrete slab. Make sure there is a grill or some kind of access. It's always fun to look into the well to see how the water is going in, the rate at which it percolates into the ground. The point to think about is when we are putting water into the ground, how do we put it, how much and where, and how do we make sure that maybe it's coming back to us or it's at least available to the city at large. The simplest structure has been seen, the simplest and most cost-effective structure, and that can be built with regular local skills, not requiring any expensive machinery, is the recharge wells. Let's also look at Bangalore's hydrogeology. What we see is that from ground to about 5 feet below is what we call topsoil. Any rainwater or water that percolates into this depth is often lost to evapotranspiration. What that means is when the sun shines brightly, this water evaporates, the plants pull it up. So not a lot of this contributes to groundwater. It's not water that I can draw out again and use as a source of water. That's the top 5 feet. When you go below 5 feet, and these depths are variable, from 5 feet to up to 100 feet or 300 feet, we have what is known as a permeable zone. Think of this zone as some kind of rocks that have weathered over a period of time to become something like sand. It is like a sponge. Water that you put into this zone goes out into the soil very easily, percolates and is held in the soil. Some of this actually goes below, which is where we come to the deeper layers, which we call the deep aquifers in Bangalore. Here it is hard rock. We are sitting on granite and gneiss rock formations which are very hard. In these rocks there are cracks and fissures in which water is held. When we dig a bore well, it is from these layers that we are drawing out water. What we have seen is that you can do recharge to any of these layers. You could be recharging these deep aquifers in hard rock, you could be recharging the shallow aquifer. But what works best is when you dig recharge wells and recharge the permeable zone or the weathered zone. What that results in is that the shallow aquifer becomes saturated over a period of time. In fact, in many of the apartments, what they have done is revived old open wells and recharged them such that that has become an additional source of water for them. Some of this water also percolates deeper down and recharges the bore wells. Once you start doing, you will realize how quickly in certain cases your bore wells can get revived or start yielding water, or at the very least the water quality significantly improves. Where you had harder water earlier, the water starts to become a lot softer because of groundwater recharge. We often get requests because when we do this kind of recharge with recharge wells, we are trying to put water into the shallow weathered zone. But what if we wanted to put water directly into the bore well? How do you do direct bore well recharge? The way we do it is we dig a pit around the bore well, sometimes 6 to 10 feet deep, maybe 3 to 5 feet in diameter. This pit is then covered, filled with jelly stones. Runoff water is directed into this pit. The borewell casing, we make perforations in the borewell casing so that the water, once it comes through the channel, falls into this pit, filters through these stones, goes through these perforations in the borewell casing to the deep aquifers from where this borewell used to be able to draw water. Some of the things to keep in mind: when you make perforations in the borewell casing, make sure that you wrap it with Netlon mesh. Why do we do all this? Because the water that you put in is the water that directly goes deep into the deep aquifer. There is no capacity in the rock to further filter this water. So you have to make sure that the water you put into the borewell has no contaminants in it, because the rock has no capacity to filter this water further. We advise that if a borewell is currently yielding, don't try to recharge a borewell, because sometimes it may result in the motor getting some movements, because of which, in case the water source stops, you may blame your rainwater harvesting for it. So it's advisable, if you're doing recharge for a borewell that is currently yielding, don't make perforations in the casing, but just dig a recharge well adjacent to the borewell. Wastewater that is generated in an apartment can be very easily treated in an STP. STPs follow different kinds of technologies. The commonly used one is the activated sludge process, then there is a sequential batch reactor. There is a range of technologies. These are electromechanical STPs. You could also have low energy plant-based STPs which use similar technologies but which are slightly slower in process and give you treated wastewater as well. So once the choice is made between these two technologies. The other thing also to see is for every say 10 liters of water that you use, roughly about 9 liters of water is what comes to the STP. Some of it, the water is lost in the process of coming to the STP. From the STP again, close to 90% of the water is retrieved. This treated wastewater is commonly used for flushing, in fact mandated to use for flushing and for landscaping. However, in apartments what we see is that there isn't a whole lot of area that is available for landscaping. So in which case, what do? There are a few cases in Bangalore when people further treat this water, tertiary treatment, where they bring it to potable water quality standards, mix it with another source of fresh water and use it for all domestic purposes. That is also something that can be carried out. Of course, there is a capital cost that is required to set up these tertiary treatment plants. Now, given the entrepreneurial spirit in Bangalore, we do have a company that also steps forward and is agreeable to bear this capital cost of setting up this tertiary treatment plant. So they buy your treated wastewater, treat it further, and then if you would want to have it back, they can sell that water right back to you for you to use, or they sell it to other industries or malls where there are industrial applications for it, say in a cooling tower or some kind of manufacturing processes. Explore these options as well. Each of these activities that we spoke about take their own time, takes a change of mindset where people have to agree, and that is often the challenge with apartments, because you need to get the collective to form a certain decision. It takes time, it takes effort, it takes money, it takes patience. So you have to ensure that all kinds of communication channels are kept open. It could be online communication where you're sending out posters, emailers, WhatsApp messages. It's good to have physical presence events. You can involve children, involve larger communities where you speak, share about these best practices and resolve all the questions that people in your apartment may have, such that you are able to implement each of these best practices over a period of time.
It's very important to remember that when we manage our water and our waste, we stand on the shoulders of people who we call labor. So it's very important to recognize that our partners in all of this are the plumbers, the well diggers, the masons, the sanitation workers. And it's important that we respect them, that we give them dignity, that we ensure their safety and their insurance, that they are sources of knowledge and that we invest in their knowledge and in their skills. In good water and waste management, it's very important to monitor and document things very regularly. So be it your sources of water, how much they are yielding, what the levels of water are in your wells and in your bore wells, regularly monitor them and document them. What the quality of water is, regularly test your water once in 6 months, once in a year. Keep testing and keep monitoring. In good water and waste management, it's very important to monitor and document everything in your system regularly. It's very important to constantly monitor the yield of your bore wells, your depth of your wells, bore wells, or all your sources of water, the quality of all your sources of water. It's important to monitor and document the performance of your STPs, of your recharge wells, of everything that you have in your system. Have a regular system of monitoring and documenting it. Here again, your laborers, what you call your laborers, are a very important part of this whole monitoring and documentation bit. You need to invest in their skills so that they become a part of the monitoring and documentation, so that they bring their everyday stories of your STPs, wells and bore wells into your documentation process, and you are able to capture the knowledge that they bring into this process. Equally important and good management of your water systems is regular maintenance. Regular maintenance, for example, of your recharge wells, where you look at it once in 3 years to look if it needs desilting, if it needs some rings to be replaced. Here again, well diggers are going to be our partners, and remember that they are sources of knowledge. They can make observations to bring you insight into what's happening, and they are not just people who dig your wells. Similarly, in your rooftop harvesting systems, make sure your catchment is clean, look at your filters regularly, clean the filters regularly, and observe the quality of water that's coming out as a result of harvesting your rooftop rainwater, and get it tested once in 6 months or once in a year regularly. Then, when you're maintaining your STPs, remember that the sanitation workers who are going to work there put themselves at great risk. Ensure that they use the appropriate set of personal protective equipment, and make sure you're not violating the PEMSR Act 2013. That is the Prohibition of Employment of Manual Scavengers and their Rehabilitation Act, where you have to make sure that nobody is sent into confined spaces where there is sewage or fecal sludge. This can put their life in danger. Make sure you're very ethical about how you maintain your STP, notwithstanding some incremental costs. Just to summarize all the good practices in water management that you can employ, think of the entire journey of water, from where it begins to where it ends after you use. So you begin with your sources. It may be your bore wells, your wells, municipal supply, even tanker water supply. But do you understand your sources? Do you understand your well? Do you understand your bore well? How much does it yield? Which bore well is the most important bore well in your layout or your apartment? These are very important things to capture, right? These are things where you have to invest in understanding. So that's your first step in good water management. Secondly, understand what your demand is. Who's consuming how much? What is the water being consumed for? Can you actually reduce your consumption? How can you reduce your consumption? Can you make your taps more efficient with fixtures? Can you actually become more conscious about how much water you use and reduce the water you use? Are you sure you're not leaving your tap open when you're brushing your teeth and you don't really need to have the tap open? All these are very important things, and all these are often a result of constant communication with the community you are working with. So that's very, very important. Finally, if these stories and if these messages need to go and sink into everybody's heads, meter every consumption point. Every household can be metered, and so that every individual, every household understand how much water it's consuming and becomes conscious about the water it's consuming. So metering, and then setting appropriate tariffs and setting volumetric increasing block tariffs, meaning to say that everyone pays based on how much water they are using, and you are recognizing that the first n,000 liters, which you can decide for your own community what that n,000 liters should be, but that is everyone need to use. It's a right to life. But for every bit of water used beyond that, you begin to send signals to the community that they are either being wasteful or they are being conscious, and let your tariffs reflect that, and let therefore your water bill become a story you communicate, you use, the water bill becomes a way to communicate this story to the community, right? So this issue of managing the demand is extremely critical, because if you manage your demand, if you reduce your demand as much as you can, then be it managing the supply of this water, be it managing the wastewater that you generate, then becomes that much simpler. It becomes that much cheaper. It can make the difference in a community between investing in a 250 kiloliter per day wastewater treatment plant and a 150 kiloliter per day wastewater treatment plant. It means completely different economics, and therefore this issue of managing your demand should be considered very, very important. As you work for managing your demand, you can actually start looking at each household within the community as a place to harvest rainwater. Rooftops are usually clean surfaces, so you can capture rooftop water, store it in tanks, and the household can actually use it. And this much water the household now does not need to depend on the community's water supply. Similarly, water that's falling on clean roads or water that is not being able to be stored in storages from rooftops can all be led to recharge wells. So you can capture rainwater from common catchments and private catchments which you cannot store and ensure that you recharge groundwater, because we are all dependent on groundwater either through wells or through bore wells. When we are recharging water, however, remember that the quality of the water we are recharging should be clean. We should ensure that it's not getting mixed with sewage. We should ensure it's not getting mixed with solid waste. We should ensure we should put our recharge wells in appropriate places, not very close to electrical cables or sewage lines. Then, apart from rainwater harvesting, you should look beyond the journey of the water when it leaves your house, right? So all the water that you've used and is going out, can that be treated well? Can you actually separate grey water, that is the water that simply has soap, and black water, that is the water coming out of your kitchen or your toilets? Can you actually separate them and treat them separately? You should consider these options. And the water that's treated, can you at least use it for gardening? Can you at least use it for flushing, thereby reducing your freshwater demand? And again, having that virtuous cycle of saving on both resources and costs, because your demand is low. And in doing all of this, remember that plumbers, masons, ring makers, sanitation workers, well diggers are all our partners, and we treat them respectfully. We treat them as sources of knowledge and not just labor. We invest in upgrading their skills. We invest in making them a part of our solution and our solution thinking process. All of this goes to making a sustainable community, and sustainable communities make up a sustainable city. So all these practices, when you implement in your community, it may not happen overnight. It usually never happens all at one go. It takes perseverance. It's usually an incremental process implemented over time. And most importantly, it's also a process where all the residents within the community are bought into these ideas, know what these ideas mean. And it's a process of persuasion of one and everybody who then come together to implement this. And to do all of this, there is www.bengaluru.urbanwaters.in. It's an online repository of all sorts of actionable know-how, information, and helpful contacts for you to be able to implement all these good practices in your community.